this is an area where a lot of users are concerned about. We get a lot of calls about, hey, it's taken forever to simulate. What's wrong? Okay. Well, it's not that something is wrong. It's just that you probably don't have your settings set in order to get the best performance that you can get out of it. So let's just start at the top. What are the performance indicators for simulation? Obviously, it's your geometry, the stock model, the size of your stock, your control geometry, your containment area. You know how large of an area are you cutting or are you simulating? You can think of it simply as more motions, more time. Okay, the more times that tool moves from point A to point B, the more time it takes to simulate. But there's a way around that, and we're going to show you that trick in a minute. Simulation preferences obviously also play a major role in how fast you can get through a simulation. Now, some tips related to increasing your simulation time. We have different simulation models. One's called a voxel model, one's called a polygonal model. Now, just to mention, if you're using the express configuration, you only have the voxel model, so you don't have the higher accuracy polygonal model simulation. I just wanted to mention that. And then also we're going to go over what does it mean to simulate by moves versus by distance, because they're in the default settings, one is faster than the other. And then simulate until, this is a little trick that I mentioned about. I'm going to show you how to bypass everything and just cut right to the chase and get your simulation model displayed. When and how to simulate, that's basically, the way you work. There are things you need to be cognizant of, though, when you go to simulate a model that has a lot of toolpaths. And then again, in your simulation, the more accurate the simulation, obviously the more time it's going to take. Okay, so let's take a look at the default simulation preferences. So on the left, you see the CAM preferences dialog. We're looking at the simulation tab. Now, these top two areas, simulation model and simulation mode, the mode correlates to, if you look at your simulate tab down below here, you have a checkbox for simulate by moves. Okay, so this correlates to the simulation mode. But let's talk about the simulation model. For many 2-axis and many 3-axis, and Joe, you can jump in and tell me which ones that don't apply, but many you can run in a voxel model simulation, and you can drop that simulation time by over 300% in our tests just by using the voxel model. Now, it's going to be less accurate of a representation, but if you understand your model and how it's going to work, you can use that to get a quick view of what the toolpath looks like.
Let me jump in here, Don.
Okay.
So the voxel model, there was a question by one of our attendees who's saying, what is a voxel model? It's a good question. Everybody's heard of pixel, right? I mean, pixels are basically picture cells on your TV or on your monitor, computer monitor. Very similar to that, internally what we do in the CAM system is these pixels, instead of just pixels, we actually create volume cells. So these are, dots on the screen, but they also have a Z depth associated with it. So we call them voxels, so similar to pixels. And so you can think of it as, a voxel model is nothing but a volume model that we create of a part file or a stock file. And that's what we use for simulation. And the voxel model has restrictions because it's dependent on the orientation of the tool. And for all 3 axes and 2.5 axes, as Don mentioned, you can use the voxel model. But the minute you use different setups, as you might use in a 4-axis setting or a 5-axis index machining, then you cannot use voxel model because you're coming at the part and machining it from different orientations. and the voxel is inherently limited to the z-axis of your toolpath. So as long as you're using just one z-axis setup, the tool axis is pointing only in one direction, which most of the 3-axis toolpaths are, then you can use the voxel model. So, and it's much faster and uses a very much smaller footprint than the polygonal model. I hope that helps.
Okay, let's take a look at, a lot of users get confused about the simulation mode, okay? Now, you got two choices here, simulate by moves and simulate by distance. What this means is how many times that model gets refreshed on your screen, okay? So in the background, in the algorithm, it's calculating all the toolpaths, it's going through all the model, but you can control how many times it shows you the model during the time it takes to generate the simulation model. So if you don't care to only see the toolpath 5 times versus 35 times, then you're gonna really decrease the amount of time it takes you to get through that simulation. And you can control that by, if you simulate by moves, you can adjust this value right here, which maximum display interval. So the default display interval by moves is 100. So every 100 moves, the simulation on your screen is going to refresh. Okay, and you can increase this to say, I want to refresh every 1,000 moves, and that can really speed up the amount of time it takes to get through a complicated model. So you may, you may see a refresh, every, I don't know, I'm just going to guess, every 2 minutes, say, okay, versus one every 30 seconds, okay? And again, that's by moves. So if you pick simulate by moves, that's the fastest. And if you look down here on the simulate tab, there's a checkbox for simulate by moves. Using the default parameters, check to simulate by moves, that will be faster, okay? And then you also have a slider here, and that relates to this slider down here on the dialog. That just moves up, how many times, again, your display interval, how many times the model is being displayed on the screen. So you think of it on the slider, move to the left, it's slower, move to the right, it's faster. And then also here, you increase the maximum display interval, that's going to be faster. You decrease it, that's going to be slower. And then the simulation accuracy. If you're using the voxel model, you can enter in the volume size, as Joe mentioned, which will affect the simulation time. But you can also, go ahead.
Sorry, Don. Just wanted to correct that. It's not the volume size. It's really the spacing between each of the pixels is what you're affecting there.
Oh, okay.
So
okay.
the more the denser or the tighter the spacing, the more accurate your representation. And then one other note I wanted to add is these settings that you're changing are not going to affect your toolpath at all. The toolpath is already done. So we're just using this for simulation. So it'll affect the quality of the simulation display on your screen, but your toolpath quality is going to stay exactly the same. So.
Okay. Again, there's a slider for accuracy, standard accuracy, medium, and fine. Just be cognizant of the fact that if you, jack it up to the right, you're going to slow down your simulation time. It could be as much as 200, 300%, for, 2 or 3 times longer by using the finer simulation. So if you don't need to, there's no need to. So then also I mentioned the trick. If you want to bypass all this gobbledygook and cut to the chase, just right click on your toolpath operation and pick simulate until. That just bypasses everything. It doesn't show you anything until the end. So it's just going to calculate. It's going to calculate, and then it's going to show you the final simulation model. So if you're worried about time, go ahead and use the simulate until. So also being aware of the fact, if you're simulating until, and your operation is 12 operations down, and you simulate until, it's going to calculate all the operations prior to that. It's not going to show them. It's just going to calculate them, and it's going to get to the one that you simulate until, and that's the one that's going to show on the screen. So in most cases, if you just want to see the simulation, just pick simulate until, and it'll bypass all this other stuff that you if you don't want to worry about it. So there are a couple of things that was interesting though in our tests. In our tests with the shoot, Joe, that word just kept out of my mind. The shoot, let's go over here. That is the material texture. So what I'm getting at here, if you assign a material texture and you have it displayed, it reduces your simulation time by 25%. Now, why was that? I haven't figured that one out yet, but that's the result that we got in our test. So
it depends on your graphics system too. So
yeah.
graphics card. So some graphics card can do it in the hardware, the texture display.
Yeah.
Texture display typically would take longer because you're adding additional, computations for
So
displaying.
basically what we're saying then, if you have a so-so graphics card, that might take longer.
Right.
Yeah. If you have a good one.
Mm-hmm. Yeah, the more you tax your graphics by adding textures and different light sources and things like that, it's going to slow things down. So
okay. Well, I guess on this, because we had a good graphics card in this machine, it actually went faster. So that's just something to think about. So also over here, if you if you're in a pro or premium configuration, if you going to simulate your machine tool, that's where you have your machine tool on the screen, and you're actually seeing the axes of the machine tool simulate along with the part. Just be aware that's going to tax your system another 15%, so it's going to slow it down. Okay, so let's. We got about 5 minutes. I'm going to try to show you a few simulation things before we end up here, and I wanted to go into this part here. I want to show you the voxel simulation. So let's go over to simulate. Let's go to the preferences, pick the voxel model, and we're going to pick OK. And we're going to run through the simulation real quick. So this is how fast it went through on the roughing operation. It took like 2-3 seconds. Now, Joe, you mentioned that there is some artifacts in the Z-axis. If you zoom in and you see these, this is not in your toolpath. Those vertical artifacts.
That is the voxels. You're basically looking at the voxels displayed there.
Mm-hmm. So don't worry, it's not in your actual toolpath. So let's do the parallel finishing on the voxel. So it's going to whip through that pretty fast. So that's like, I don't know, 2 seconds, 3 seconds. Now, if we did that with the polygonal display, click OK. And we'll check our preferences. Okay, I have it set to 1000, so it's going to be pretty fast. Let's see how much faster or how much slower it is than the voxel. We'll run the horizontal roughing. So it wasn't a whole lot slower. Now, that's one thing I was mentioning. By default, this is only 100 for simulate by moves. So that by default, you're going to see 100. So if you just did this by default and you simulate it, it's a little bit slower. Okay. Just, that's something to be aware of. If you're going in a simulation, it's taking forever. Don't worry. Just jack this number up. I jack it up to 1000. Let it only, update the display every 1000 moves, and then simulate it again. You'll see that it goes faster. And let's do the simulation, the parallel finishing. There's a lot of tool paths on that parallel finishing path. I showed you them a moment ago, really dense step over, but it's cutting through it pretty fast. So let's just pick pause and go to end. Doing that.
Looks like we lost Don there. Don.
Can you hear me?
Yeah, you're
Okay.
back now.
Okay, sorry about that. Looks like I locked up the part because I did oh, there it is. It freed up on me. So, it gives you an idea. I turned down used the polygonal simulation, which was slower, turned down the number of displayables so slower, so it just slowed down everything. So on the simulation performance, let's see if there's anything else I want to show you. Joe, we got any questions? We're about right at an hour. I think I'll stop it here.